Hello, Algebra 1, and welcome to 12.4, Multiplying Rational Expressions. Yes, we skipped ahead a little bit, but it'll be nice and easy here for our notes today. So let's get right on into it. The essential question: how do you multiply rational fraction expressions? Okay, a lot of these topics deal with factoring and everything that we have worked on before. That's why we reviewed it yesterday. So our first bit of information for this new piece is something called checking for excluded values. And that is simply where the denominator is equal to 0. All right, well, why can't we have a denominator equal to 0? I wonder. If you recall, so if you try and type something like 1 over 0 in your calculator, it's undefined. Okay, so our first task is we're kind of like bouncers at a party or something like that here. So we're going to look at letter A, and we want to know what values of x aren't allowed. So what values of x aren't allowed in the door? And to do that, it's really easy. All I'm going to do is take the denominator. That's the only thing I'm concerned about. The only thing is the denominator, and I'm going to set it equal to 0 to find out. So where is negative 2x equal to 0? Well, if you divide each side by negative 2, you can divide 0 by negative 2, x equals 0, which really means the excluded value, we can't let 0 into the party. Okay, every other value is allowed except for 0. 0, not coming in, bud, sorry. The next one, again, the only thing you're doing, setting the denominator, equal to 0. Okay, so let's find out what's not allowed at the party. So you're like, all right, checking IDs and everything like that. You're going to add 9 over. Okay, these should be basic problems. You divide by 3. You divide by 3. So that means x is equal to 3. And again, if you're checking, that means technically we can't allow 3 into the party, because if you put that in there, you would have x over, let's think, 3 times 3 minus 9. So you would have x over 0, and that would not be good. Okay, so our last one here, oh no, they're looking challenging. It's easy peasy. Okay, so here's where factoring comes back into play. Well, x squared, you're going to look at factors of negative 15. I believe they come out to be 5. And we're looking at 3 as well. Now, which one will have to be positive? The larger one, x plus 5, x minus 3. And here we actually have two things that aren't allowed at the party. So it's almost like solving. We're going to say, where's x minus 3 equal to 0? Well, that's at x equals 3. He's not allowed. And where's x plus 5 equal to 0? Well, that is x equals negative 5. And perhaps she is not allowed. So 2 values not allowed in the party. Everything else can be, okay? Now they get a little more challenging. So we're going to simplify, but we always, and when I tell you to find excluded values, you want to do that first before you simplify. I know it's tempting to just jump on in and cancel things out, but find excluded values first. You got to check your list. So let's take 15x to the 5th. Where is that equal to 0? Well, if I divide by 15, it's saying what times itself 5 times is equal to 0. And this may look tricky, but really 0 times 0 times 0 times 0 times 0, x equals 0. That is what's not allowed. And from there, it's nice and easy. So if we look at this as 3 over 15 times x to the 3rd over x to the 5th, well, 3 over 15, you can even type that in your calculator. You should know that's 1 over 5. And x to the 3rd over x to the 5th, this is why we did exponent stuff. This is really 1 over x squared, And if you combine that little thing, it's just 1 over 5x squared. Okay? Check for excluded values first. Okay? This next guy. So we're going to do what first? Check for excluded values. Divide. Well, first we're going to add 21. We have 7x equals 21. Divide by 7. So what's not allowed at the party? But you're like, 3 is not allowed. From there then, we also, so what else did we work on yesterday? Removing common factors. X minus 3 with a 7 out front. How did I go from there to there? I removed the GCF. All this stuff is going to come back. So up top we have 28x. This is going to simplify further. 28 and 7 each have a factor of 7. So if you do that, it is simply 4x over x minus 3. This is your answer. Do not, and you don't need to write this down unless you really think so, do not cancel the x's in this particular case. Okay? Do not cancel them out. I'll show you another example in a little bit that maybe you would, but in this case, this is what you will leave it as. Okay? So let's look at another example. Oh my goodness, it looks so challenging. First, what do we got to do? Check the roster. So x squared minus 2x minus 63. Where's that equal to 0? Well, I'm going to factor it out, and that's going to be 9 and 7, negative and plus. So x cannot be 9, and x cannot be negative 7. Those two things are not allowed. Now, the whole idea of factoring here, some cool stuff kind of happens, okay? I already factored the denominator into x minus 9 and x plus 7 when I checked. So checking for zeros automatically kind of helps you out. What else can I do? I'm going to factor the top. Well, let's see. Factors of 42 that add to 13. 7 and 6, both of those positive, add to that. Now here's the cool thing. When everything's factored, well, you get to play chef or whatever, and you get to cancel stuff on out. So once everything's factored, you can just boop, boop, cancel out whatever's the same. X plus 7 and x plus 7, they are gone, leaving us with x plus 6 and x plus 9. Again, these do not cancel. I will even highlight more that these are different. So that leaves you with x plus 6 over x minus 9. Okay? That is simplified then. Now keep in mind, x can't equal 9, and it also can't equal negative 7. Okay? Moving on, combining all this stuff. Oh my goodness. You're like, Mr. Dvorsky, are you serious? It is just factor party right here. Factoring over factoring. Now the nice thing, hey, I tell you not to worry about the restrictions, okay? There's so much going on in this particular case. We aren't going to check the rosters, but what's going to happen, okay? I recommend just kind of setting up a lot of space. So first we are going to factor. Let's factor the numerator, and let's remove or factor the denominator. Let's see what we can do, okay? Well, the numerator, again, factors of negative 6 that add to positive 1, that would be 3 and negative 2, meaning I have x minus 2 and x plus trace. Let's check out the denominator, okay? One of the little-known factoring techniques you might have forgotten is the GCF. So what do they each share? someone should hopefully be like, hey, they share 10 and x, and if you remove that, it's going to leave you with x minus 2. So that's all factoring. Now, don't cancel anything out just yet. Again, I'm just going to show you that goes there. Okay, let's take care of the other side. So, again, 5x squared plus 15x. If there's two things, generally, you're just going to remove the GCF. So that's going to be 5 out front and x, leaving you with x plus 3 all over. If we factor the denominator out, let's see, 5 and 3, a negative and a positive. Okay, that's your denominator. Everything's all factored, and once you do that, the fun begins. You cross out pairs that are alike. The x plus 3s, only 2 of those are going to cancel out. X minus 2s, those are gone. And let's see what we have left. So at the moment, we have 5x, x plus 3, all over 10x, x minus 5. And if you want to make it even prettier, what can happen here? Well, the x's will cancel, and also 5 and 10, and that will leave you with x plus 3 all over 5x minus 5. Okay, it's not too bad. It's a lot of factoring though. This next one here, don't let it scare you. It's really okay. It looks scary. Everyone sees this like, what in the world? Here's a little hint. It's really only x plus 8 over 1. This whole thing is really 4x squared over 2x to the third plus 10x squared minus 48x. And again, you might be scared because of this here. Any ideas? Maybe you're thinking to yourself, maybe like, are you just going to be quiet, Mr. D? Okay, let's remove a factor of 2x. They each share that. That's going to leave you with x squared. It's going to leave you with 5x. And it's going to leave you with negative 24. The numerator, we can't really do much with it, so it's just going to stay 4x squared. Over here, we have the x plus 8 over 1. And maybe you see it here, so again, factor, 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 factor. Red's not really going to do much, but let's see if we can break this down even more. Whoops. And that will leave us with x and x, factors of 24, 8 and 3. So, kind of simplifying, keep in mind where everything is. So all this is in my numerator, all this is in my denominator. And so just kind of pay attention. Again, this factored out to become both of these. Okay, so really, this is no longer there. It's replaced as that. Okay, I'll leave that all there though. So your fraction right now looks like 4x squared times x plus 8 all over 2x, x plus 8, x minus 3. The fun begins. Boom, 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 boom. And you're left with 2x over x minus 3. Okay, awesome stuff. What I'd like you to do now is to go back to Google Classrooms. And under your essential question, under the essential question, basically, I want you to post first, the first step in problems like the first few. So the first step in simplifying radicals, what that is. And 2, I'd like you to give your best shot at simplifying, so multiply and simplify the expression x plus 8 over x plus 2, x plus 5 times x plus 5 over x plus 8. Okay, so try those 2 things. Post your comments, 2 pieces. Step 1, how do you simplify radicals? What's the first step you do? And number 2, I would like you to multiply and simplify this expression here. So write it down, give it a shot, post your comments, and that's about it. Thanks, guys.